Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
This is SpaceTime for broadcast on the 12th of June 2020. Coming up on SpaceTime, discovery of a young nearby brown dwarf system that looks like it's forming planets. SpaceX's Starship prototype destroyed in a massive explosion. And the Russians are developing a new, cheaper commercial launch system. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered a young nearby brown dwarf with a protoplanetary disk system which could potentially be forming planets. The brown dwarf, catalogued as W1200-7845, is located just 332 light-years away, making it the nearest system of its kind to Earth. Brown dwarfs are failed stars, objects which don't have enough mass to sustain the core hydrogen fusion process which makes stars like the Sun shine. While some brown dwarfs are born as such, others start their lives as spectral type M red dwarf stars, which lose enough mass during their evolution to cease core fusion, turning them from red dwarfs into brown dwarfs. Brown dwarfs fit in this unique category between the largest planets, which have about 13 times the mass of Jupiter, and the smallest spectral type M red dwarf stars, which on average are about 75 to 80 times the mass of Jupiter, which equates to about 0.08 solar masses. Astronomers say W1200-7845 is very young, just 3.7 million years old. That compares to our Sun, which is currently 4.6 billion years of age. And its proximity means astronomers will soon be able to zoom in on this young system using the next generation of high-powered telescopes now under construction. This will allow them to study some of the earliest conditions of a brown dwarf's disk. Perhaps even learn about the kinds of planets brown dwarfs are likely to host. The new system was discovered through a program known as Disk Detective. It's a crowdsourced project funded by NASA and hosted by Zooniverse, providing images of objects in space for citizen scientists to classify with the aim of finding objects that are likely to be stars with disks that could potentially host planets. Users look through virtual reality flipbooks, images of the same object in space, taken by NASA's Wide-Field Infrared Survey Explorer, or WISE spacecraft, which detects infrared emissions such as the thermal radiation given off by gas and dust in stellar disks. Citizen scientists then classify the object based on certain criteria, such as whether the object appears oval, a shape that more likely resembles a galaxy, or round, a sign that the object's more likely a disk-hosting star. One of the study's authors, Steven Silverberg from MIT, the Massachusetts Institute of Technology, says multiple people look at each object, then give their own independent opinion, which gradually builds up a consensus, determining which are probably galaxies and which are likely to be stars with protoplanetary disks around them. From there, the science team, including Silverberg, follows up using more sophisticated methods and telescopes in order to determine if indeed they are looking at protoplanetary disks, and if so, what characteristics these disks may have. In the case of the newly discovered object W1200-7845, citizen scientists first classified it as a disk back in 2016. The science team then looked more closely at the source using an infrared instrument on the Magellan 6.5-meter telescopes at the Las Campanas Observatory in Chile. With these new observations, they were able to determine that the source was indeed a disk, not around a star, but around a brown dwarf, and that the brown dwarf was part of a moving group, a cluster of stars that tend to move across the sky. And that's important because in astronomy it's far easier to determine the age of a group of stars rather than just a single lone star. And because the brown dwarf was part of a moving group of around 30 stars, previous astronomers had already estimated the average age of the group at around 3.7 million years. And so this was also likely to be the age of the brown dwarf. And the brown dwarf is very close to Earth, just 102 parsecs away, making it the closest young brown dwarf ever detected. Now, by comparison, our nearest star system, Alpha Centauri, is about 1 parsec from Earth. And that proximity is really important because brown dwarfs are lower in mass and inherently less bright than stars, so the closer these near-stellar objects are, the more detail astronomers are able to make out. Now that they know what they're looking at, astronomers want to study this brown dwarf system using other telescopes in other wavelengths, including ALMA, the Atacama Large Millimeter Submillimeter Array in Chile. ALMA's 66 radio dishes work together as one powerful radio interferometer telescope, allowing scientists to observe the universe in specific wavelengths between radio and infrared bands. In this range and precision, researchers hope to be able to study the brown dwarf's disk in some detail, measuring its mass and radius. Silverberg says the disk's mass will let astronomers know how much material it contains, and that would provide a clue as to whether or not planet formation is possible around these systems, and if so, what sorts of planets are likely to form. The data will also help determine the kind of gas that's in the system, and that in turn will tell scientists about the disk's composition. It's a wonderful opportunity to study a substellar object in some detail. This is SpaceTime. Still to come, SpaceX's Starship prototype destroyed in a massive explosion, and Russia developing a new commercial launch system. All that and more still to come on SpaceTime. SpaceX's Starship SN4 test article prototype has exploded in spectacular fashion, erupting in a massive fireball on its South Texas test stand. The dramatic blast happened about 90 seconds after a test of the launch system's Raptor engine. Detailed investigations into the cause of the explosion are continuing, but early indications suggest a fluid hammer effect triggered by the sudden cutting off of the cryogenic liquid methane fuel supply. The pressure caused by that hammer effect could have split the fuel line, allowing the highly flammable substance to escape, quickly finding an ignition point. And of course, that's all it needed. In fact, the blast was so powerful, it sent a 20-ton stainless steel mass simulator high into the air. The Starship SN4 test was part of preparations for a planned test launch of the vehicle. The SN4 test article was the latest in a series of scale models designed to test different aspects of SpaceX's planned Starship launch system, which will eventually replace Dragon, Falcon 9 and the Falcon Heavy with a unique super heavy lift launch system capable of carrying up to 100 people at a time on interplanetary journeys. SpaceX boss Elon Musk sees Starship as being the first step in interplanetary colonization, something he believes is essential for survival of the human species. SpaceX's first scaled Starship prototype was destroyed during a pressure test last November. Its replacement, the SN1 test article, was then lost in a similar test in February. Luckily, its successor SN2 passed the same test the following month. However, the SN3 prototype collapsed during its test in April, and now the SN4 prototype has also exploded. But then again, it's all part of the learning curve. This is SpaceTime. Still to come, Russia developing a new, more economical commercial launch system. And the June solstice, an annular eclipse, and the Taurids meteor shower will be the highlights of this month's night skies on Skywatch. All that and more still to come on SpaceTime. The Russian Federal Space Agency Roscosmos says it's working on a new, more economical version of its venerable Soyuz launch system in order to better compete in the growing global satellite launch business. Engineers are focusing on changes to the Soyuz 2M rocket along similar lines to the current Soyuz 21B launch system, but without the frigate upper stage. The result should be able to carry 2 to 3 tons of payload into sun-synchronous orbit for around $30 million. Current Soyuz 2 commercial launch costs are around $48.5 million with a frigate upper stage and around $35 million without it. And time now to check out the night skies for June on Skywatch. Well, it might be the 6th month of the year for us, but June was the 4th month of the year in the old Roman calendar and was named after Julius Caesar. It also marks the time of the June solstice, which this year happens at 7:43 Australian Eastern Standard Time on the morning of Sunday, June the 21st. That's 21:43 on the night of Saturday, June the 20th Greenwich Mean Time, and 17:43 in the afternoon, US Eastern Daylight Time. In the southern hemisphere, it's the winter solstice, while north of the equator, it means the arrival of summer. The June solstice occurs when the sun reaches its northerlymost point in the sky as seen from Earth, zenith appearing to be directly over the Tropic of Cancer. The seasons are all governed by the tilt of Earth's axis as it journeys around the sun in a year. On the day of the June solstice, Earth's south pole is tilted at 23.5 degrees away from the sun, so the sun rises north of east and sets north of west. When the south pole is tilted towards the sun, it's the southern hemisphere summer. In the southern hemisphere, June is a great time to look up at the night skies and marvel at the majesty of the Milky Way as it puts on a spectacular overhead display. Almost directly overhead this time of year, we have the constellation Virgo. Virgo was the goddess of justice and the harvest in ancient Greek mythology, who used her scales to weigh good and evil. However, she became so disenchanted with the evil deeds of men that she threw away her scales and retreated to the heavens. Interestingly, like the Greeks, the ancient Egyptians also associated Virgo with agriculture. Only there she was the goddess Isis, who sprinkled heads of wheat across the sky, forming the Milky Way. Of course, in astronomy, Virgo is a tightly packed region containing some 2,000 galaxies, all gravitationally bound into a giant galaxy cluster located some 60 million light-years away, with our own local group of galaxies considered an outlying member. This is the Virgo cluster, at the very heart of the Virgo supercluster, one of the largest known structures in the universe. A massive galactic node in the large-scale cosmic web-like structure of the universe. The mass of the Virgo supercluster is so great, its gravity generates the Virgo-centric flow, causing our galaxy, as well as Andromeda and all the other members of our local galactic group, to move towards the supercluster at around 400 kilometers per second, counteracting the accelerated expansion of the universe over cosmic timescales. The Virgo supercluster is now thought to be simply a lobe of an even bigger galaxy supercluster known as Laniakea, the center of which is simply referred to in astronomy as the Great Attractor. Despite the Virgo cluster size, it's so far away it's hard to see without a decently sized backyard telescope, at least 100 millimeters in diameter or larger. Now, also directly overhead right now is the constellation Corvus the Crow. Greek mythology tells us Corvus was a clever crow who could speak to humans, but he was also a lazy bird, and so the god Apollo took away his ability to speak and banished him to the heavens. One of the highlights in the constellations Virgo and Corvus is the spectacular Sombrero Galaxy, M104. M104 is located some 31 million light-years away, and is moving away from the Milky Way at about 1,000 kilometers per second. A light-year equates to around 10 trillion kilometers, the distance a photon can travel in a year at the speed of light, which is about 300,000 kilometers per second in a vacuum, and the ultimate speed limit of the universe. The Sombrero Galaxy has a diameter of around 50,000 light-years. That's around 30% the size of the Milky Way. It's surrounded by up to 2,000 globular clusters, and it has an active central supermassive black hole at least 1 billion times the mass of our Sun. Now, by comparison, Sagittarius A star, the supermassive black hole at the center of our own galaxy, the Milky Way, has just 4.3 million times the mass of the Sun, a veritable pipsqueak in comparison. Globular clusters are tight stellar spheres containing literally millions of stars, which are thought to have all originally formed at the same time in the same collapsing molecular gas and dust cloud. The brightest star in Virgo is Spica, a spectroscopic binary located around 250 light-years away. Spectroscopic binaries are systems containing two stars which orbit each other so closely they can only be separated by their spectroscopic Doppler shift as they orbit around each other. One of the stars will be slightly red-shifted as it moves away from the Earth, the other slightly blue-shifted as it's moving towards the Earth. Looking about 20 degrees above the western horizon in the early evening this time of year, you'll see the fourth brightest celestial object in the sky, the dog star Sirius. Only the Sun, the Moon, and the planet Venus look brighter. Looking to the northwest, or to the right of Sirius, is another fairly bright star called Procyon, the brightest star in the constellation Canis Minor, the Lesser Dog. In Greek mythology, Canis Major and Canis Minor were Orion's hunting dogs. Procyon is a binary system comprising a spectral type F main sequence white star, Procyon A, and a faint white dwarf companion, Procyon B. Main sequence stars are those undergoing hydrogen fusion into helium in their core. Astronomers describe stars in terms of spectral types, a classification system based on temperature and characteristics. The hottest, most massive, and therefore most luminous stars we know of are spectral type O blue stars. That's followed by spectral type B blue-white stars, then spectral type A white stars, spectral type F whitish-yellow stars, then comes spectral type G yellow stars. That's what our Sun is. Continuing down the scale, we have spectral type K orange stars, and then the coolest and least massive stars known are spectral type M red stars. Each spectral classification can also be subdivided using a numeric digit to represent temperature, with 0 being the hottest and 9 being the coolest. And then you can add a Roman numeral to represent luminosity. So when you combine all these, our Sun becomes officially classified as a G25 yellow dwarf star. Now included in the stellar classification system are spectral types L, T and Y, which are assigned to brown dwarfs. The white dwarf, Procyon B, has just over half the mass of the Sun and a diameter of around 8,600 kilometers. Located about 11.6 light-years away, Procyon A, Procyon B's binary partner, has about 1.5 times the mass and twice the radius of our Sun. Interestingly, it has about 7 times the Sun's luminosity, making it unusually bright for a star of this type. And that suggests that it's starting to evolve off the main sequence, meaning it's fused almost all of its core hydrogen into helium. So it'll start expanding out into a subgiant as it begins fusing core helium and burning hydrogen further out from the core. As it continues to expand, the star will eventually swell out to somewhere between 80 and 150 times its current diameter, becoming a red or maybe orange giant. This will probably happen within the next 10 to 100 million years. The two stars, Procyon A and B, orbit each other every 40.82 Earth years, at an average distance of 15 astronomical units. That's about the distance of Uranus's orbit around the Sun. An astronomical unit is the average distance between the Earth and the Sun, which is about 150 million kilometers, or 8.3 light minutes. Okay, turning to the north-northwest now, and you'll find the constellation Leo the Lion, looking like a bunch of stars shaped like an upside-down question mark. There, you'll notice the star Arcturus. It's a bloated, aging red giant, about 7.1 billion years old, nearing the end of its life. It's located some 36.7 light-years away. Having now used up all its core hydrogen fuel, it's fusing helium into carbon and oxygen. And this has caused the star, which really is only slightly more massive than our Sun, to expand out to around 25 times the Sun's diameter and become about 170 times as luminous. It'll soon puff off its outer gaseous envelope as a planetary nebula, revealing its white-hot stellar core, a white dwarf, a preview of what one can expect from our own Sun. In Greek mythology, Arcturus was the guardian of the bear. Now this is a reference to it being next to the constellations Ursa Major and Ursa Minor, the greater and lesser bears. There's some indications that Arcturus could have a binary stellar companion, but at this stage results are still somewhat inconclusive. There's also speculation that it could have a large planet or a substellar object of about 12 Jupiter masses orbiting it. In other words, a possible brown dwarf. But here again, the search remains inconclusive. If you turn to the east, you'll see the 3 brightest stars in the constellation Libra, signifying the scales of justice, and are visible about 40 degrees above the horizon. These stars also represent the claws of Scorpius the Scorpion, which is chasing Orion across the sky. The brightest star in the constellation Scorpius is Alpha Scorpii, or Antares, the Scorpion's heart. Antares can be easily seen with the unaided eye, not bad for an object some 550 light-years away. That's because it really is big. It's a red supergiant, and it happens to be one of the largest known stars in the universe. It has about 18 times the mass, and a spectacular 883 times the diameter of our Sun. Antares is some 10,000 times more luminous than our Sun. A spectacular sight in any night sky. Now looking to the southeast, you'll see the constellation of Sagittarius, the Archer. Of course, Sagittarius marks the direction of the centre of our Milky Way galaxy. Located some 26,000 light-years away, it's the home of the galaxy's central supermassive black hole, Sagittarius A star. To the ancient Babylonians, Sagittarius was the god Nergal the centaur, a creature half man and half horse. By the time Greek mythology took over, Sagittarius was carrying his bow loaded with an arrow pointing directly towards Antares, the heart of Scorpius the Scorpion. The centre of the Milky Way and its supermassive black hole Sagittarius A star lie in the westernmost part of Sagittarius. The brightest star in Sagittarius is Epsilon Sagittarii, or Cars Australis, the southern part of the bow. Epsilon Sagittarii is a binary system located 143 light-years from Earth. The primary star is an evolved spectral type E blue giant, now nearing the end of its life on the main sequence. It has about 3.5 times the Sun's mass, almost 7 times its radius, and it's radiating some 363 times the Sun's luminosity. It's also a strong X-ray source, and is spinning very rapidly, with an estimated radial velocity of some 236 kilometers per second. The system also displays an excess of infrared radiation emissions, suggesting the presence of a circumstellar disk of dust. The second star in the system appears to be inside this debris disk. Astronomers think it's a spectral type G yellow dwarf star, similar to the Sun with about 95% of the Sun's mass. The Sagittarius constellation also hosts many star clusters and nebulae, including some of the best-known astronomical objects in the sky. These include the spectacular pink emission lagoon nebula Messier 8, located some 5,000 light-years from Earth and measuring 140 by 60 light-years across. The central region of the lagoon nebula is also known as the Hourglass Nebula. That's because it has a distinctive shape caused by matter being propelled by a massive star-forming region known as Herschel 36. Herschel 36 is one of the few star-forming nebulae which can be easily seen with the unaided eye. The Lagoon Nebula plays an important role in astronomy because it was instrumental in the discovery of Bok globules, more than 17,000 of which have now been found in the nebula. Astronomers believe that Bok globules contain embryonic protostars destined to eventually become new stellar generations. Also in Sagittarius is Messier 17, better known as the Horsehead Nebula. Located some 4,890 light-years away, it's a dense region of ionized atomic hydrogen, which really does look like a horse's head. Also known as the Omega or Swan Nebula, it spans some 15 light-years across and has some 800 times the mass of our Sun. It's considered one of the brightest and most massive star-forming regions in our galaxy, with a geometry that's very similar to the Orion Nebula, except that we're seeing it edge-on rather than face-on. The open star cluster NGC 6618 lies embedded in the nebulosity and causes the gases of the nebula to shine due to intense radiation from these hot young stars. Open star clusters are loosely bound groups of maybe a few thousand stars, which were all originally thought to form at the same time in the same molecular gas and dust cloud, but they're not as densely bound together as globular clusters. It's thought open clusters generally survive for only a few 100 million years before the various stars in them gradually drift apart. Now, by contrast, the more massive globular clusters exert such a strong gravitational attraction on their members they can survive for maybe 10 or 12 billion years. The Horsehead Nebula is thought to contain up to 800 stars, including over 100 of the most massive spectral-type OMB blue stars. And also more than 1,000 additional stars are being formed in the surrounding molecular gas and dust clouds. Another spectacular object to look for in Sagittarius is the Trifid Nebula, Messier 20. It's a large star-forming emission nebula containing many hot young stars. Located between 2,000 and 9,000 light-years from Earth, the Trifid Nebula has a diameter of approximately 50 light-years. The outside of the Trifid Nebula is a spectacular bluish reflection nebula, while the inner regions glow pink thanks to ionized hydrogen. Also, there are 2 dark bands dividing the Trifid Nebula into 3 regions or lobes. Hydrogen in the nebula is being ionized by a central triple star system which forms the intersection of the 2 bands, in the process creating the characteristic pink color. The month of June also marks the first of 2 annual encounters with the Taurids meteor shower. The Taurids are generated as the Earth passes through the debris stream created by the comet 2P Encke, which itself could be a piece of a much larger comet that probably broke apart around 20,000 to 30,000 years ago, most likely following numerous interactions with the powerful gravitational field of Jupiter. As their name suggests, the Taurids' radiant or apparent point of origin is in the constellation Taurus the Bull. The Taurids' meteor showers are made up of larger, more massive material. Think of pebbles instead of dust grains. Earth passes through this stream twice every year, once in June, then again in October, when they're called the Halloween fireballs. The Taurids release material both by normal cometary activity and also occasionally by close encounters with the tidal force of the Earth and other planets. And that makes the Taurid stream of material the largest in the inner solar system. Now, since this meteor stream is rather spread out, Earth takes several weeks to pass through it, causing an extended period of meteor activity compared with the other much smaller periods of activity from other meteor showers. Also included in the Taurid stream is a denser flow of more gravelly meteoroids known as the Taurid swarm. It's thought to be a ribbon of rocks roughly 75 million by 150 million kilometres across, and appears to be held in orbit by Jupiter's gravity. Now, occasionally the Earth will pass through the larger meteoroids in this denser Taurid swarm. And it was one of these larger chunks of meteoroids in the Taurid swarm which is thought to have caused the now infamous Tunguska event in the skies over Siberia on June the 30th, 1908. The Tunguska event is believed to have been the airburst of a 100-metre wide meteor over the Tunguska region of Russia, causing mass devastation and flattening over 2,000 square kilometres of forest into matchsticks. In fact, the blast from this event was so bright, it lit up the night sky in London a third of the way around the planet. Tunguska remains the largest known Earth impact event in recorded history. Jonathan Alley, the editor of Australian Sky and Telescope magazine, joins us now as we continue our tour of the June night skies.
It's June now, so that means for us in the Southern Hemisphere at least, it's winter time, so
cold.
It's cold outside there, but it's really good stargazing time because the nights are long and they're dark, and we've got the Milky Way. This time of the year, you go out in the early to mid-evening and you have the Milky Way stretching right across the sky from the east to the west. It's tremendous, and you've got Scorpius and Sagittarius and Scutum. That's another constellation you probably haven't heard of, but Scutum. All around that area there, we're looking towards the centre part of our galaxy. Stacks of things to see if you have a small telescope, star clusters and things and beautiful nebulae. It really is a wonderful, wonderful vista that you can get looking through our Milky Way. It's a really good time of year, actually, for stargazing.
You're almost beside yourself there with excitement.
No, there's no one beside me. It's just me right here. But
at least you have each other.
Oh, dear. Well, let's just have a look through the Milky Way. So we'll start where we usually start, right down south, the Southern Cross, which is, for once, nice and upright, standing the right way up in the middle evening during June. It's wonderful. It's really quite high up in the sky. You can't miss it. It looks like a small kite, and it's got the two pointer stars just off to its left. So that's really easy to see. You can see it from anywhere around Australia.
And very exciting news that the second of those two pointer stars, Alpha Centauri, that's the pointer star furthest from the Southern Cross, we now know that one of those stars, Proxima Centauri, has a second planet orbiting it. Proxima C, just discovered. Very exciting stuff.
Well, Proxima Centauri is the closest star to Earth.
Exactly.
Other than the Sun, of course. So that now we've got some close-by planets or exoplanets, as they call them, of course, ones that orbit other stars. We've got some ones that we can probably get some really good info on. So it's good stuff, isn't it?
Indeed, yeah. Well, Proxima B has always been a favourite because it's so close. It's within the habitable zone of the star. But being a red dwarf, there's probably not much happening there. Anything on the surface would have been irradiated long ago. But there's this new one, Proxima C, much further out, about 1.5 astronomical units. Yeah, it's a second planet. We don't know much about it, about 7 times the size of the Earth. That's all, or the mass of the Earth. That's all we know at this stage, but very exciting.
It is very exciting. Now, Proxima Centauri, that star is far too faint for you'd be able to see with the naked eye, but get out and have a look at the two pointers, because it's more or less in that same direction there, and you'll know that somewhere out there is that star with those couple of planets going around it. So yeah, when you think of it like that, when you try and connect it with stuff that we know, and then you go outside and look at stuff in the sky, and you think, I know what's going on out there, or we have a bit of a hint. Yeah, that's really what it is. It's quite amazing. So there's the Southern Cross and the pointers down the south. Over in the west, just above the horizon, you've got the brightest star in the night sky, Sirius, and around to its left, you've got another really bright star, in fact, the second brightest star in the sky, called Canopus, and that's in the constellation Carina. Now, if you're in a dark location, you've got clear skies and you have an unobstructed view down to the south, so there are no mountains or hills or buildings or whatever in the way, then you should also be able to see in the nice dark winter nights are the two Magellanic Cloud galaxies. So they look like just faint, really faint clouds, literally like clouds, but they are actual galaxies, fairly sizable galaxies, very close to our Milky Way. And again, when you're looking at them, you're looking at over 100,000 light years to each of them. So, and these are composed of, millions of stars. So it's just amazing, amazing to see this other galaxies outside our own galaxy. There are only a handful of galaxies you can see with the naked eye that are beyond our own galaxy, and you need dark skies. But that's really good stuff. Now, on the north of the sky, I have to say the northern half of the sky from down here in the south, this time of the year does look really quite bare, okay? There doesn't seem to be a lot going on. You've got the bright star Arcturus, which can be seen about halfway up from the northern horizon. Overhead, we've got another bright star called Spica. That's a really good one to see. As the night goes on, though, you'll see that things change because the Earth is turning and we see different parts of the sky. So by midnight, that Sirius star we were talking about, that's well and truly set in the west. You've got the bright stars Vega and Altair have appeared up in the north, and you've got the bright star Achernar, which has appeared down in the southeast, and the Milky Way, which was stretching east to west across the sky, will be now stretching north-south across the sky. That's because the Earth is turning on its axis and we're just getting a different sort of view. So it's good to see, if you go out and say, I don't know, 7 o'clock, 8 o'clock or something, have a look where the night sky is, have a look where things are in the night sky, then go out again before you go to bed and see how it's moved, see how everything's changed. And that's just the Earth turning on its axis. It's really quite a good demonstration that the universe is dynamic and that nothing really stays still. Speaking of not staying still, we've got the planets. The planets, of course, comes from a Greek word meaning wanderers, so they're not standing still either. We've got Mercury, which can be seen in the northwest after sunset, but fairly low down, okay, and it's going to move lower and lower towards the horizon as the days pass, and by about the beginning of the last week of June, it's going to be too hard to see. Another one that's hard to see, in fact, it's out of sight at the moment, is Venus, which is between the Earth and the Sun right now at the beginning of June, but it's going to reappear in our morning sky out to the east in the second half of June. You won't be able to miss it. As soon as Venus comes up over the horizon, you know what it is because it's really, really big and bright, like a big bright star, the biggest and brightest star you've ever seen. Mars is rising just before midnight at the moment, so look out to the east if you're still up at that time of night. You'll be able to see it quite easily. It looks like a sort of a medium brightness, reddish sort of star.
And another launch towards there next month too.
Oh, a few launches actually. I haven't got. What have we got? We've got Perseverance, the Yanks.
Yep.
Is the United Arab Emirates one still going? And what about is there a Indian one going? The European one's got put back, I think. Let me see. We've got July 14th, the last time I looked, we've got the Emirates Mars mission, which is going to launch from Japan. And then a few days later, you've got Mars 2020, the Perseverance one from the Yanks. Sometime in July, the date not set yet, is the Chinese, the Tianwen one mission to Mars, It's going to be a robotic mission, includes an orbiter and a mobile rover. They said
mobile rovers are always the best.
It's distinct from an immobile rover. Yeah, they're really pretty good, aren't they? So there you go. So the three, and the European one they put back because of COVID thing. They just couldn't get it ready in time. They were just running a bit behind, and they thought, when are they going to get there? So Jupiter and Saturn are also above the eastern horizon, but earlier in the night they're both up by around about 7:30 or so, and they just get higher and higher as the night goes on, as the Earth turns. They both look really big and bright. You can't miss them, and both planets are heading towards what we call opposition next month. Opposition is when a planet is in one direction in the sky, as seen from Earth, and the Sun is in the other direction in the sky, directly 180 degrees opposite, which means, in practical sense, when the Sun goes down in the west, these planets come up in the east. And that means then you've got all night to see them as they rise up in the sky and go across overhead and down towards the opposite horizon, and they set when the Sun is coming up the next morning in the east. So as long as you've got good weather, you can study these planets all night long. And opposition, not the same as closest approach, like the closest distance, but it's usually within a few days or a week or so. So in practical purposes, opposition also means that's when the planet is more or less closest to us. So it looks bigger when you look through a telescope, so you get a better view. Mars is heading towards opposition in October. It's going to be a reasonable sort of opposition in terms of how close Mars is and therefore how big it will look through a telescope. But it's going to be the last really good one until about, I think, the 2030s, 2036 or so. Everyone between now and then, Mars is going to be a bit further away than normal, so look a bit smaller. Mars is a small planet to begin with, so every little bit of advantage you can get by having it closer, you get a much better view. Now, our planet Earth is going to reach solstice on June the 21st. This is when the Sun is farthest north in the sky during the middle of the year, and the days are shortest and nights longest in the southern hemisphere, and vice versa, of course, in the northern hemisphere. But on the same day, at the solstice, there's actually going to be an event to see in the sky, and that's going to be an annular eclipse of the sun. An annular eclipse is different to a total eclipse in that the moon doesn't quite fully cover up the disk of the sun. Because the moon's orbit is an ellipse, sometimes the moon is a bit closer and sometimes the moon's a bit further away. And when it goes in front of the sun, when it's a bit further away, when the moon's a bit further away, the moon, by definition, looks a bit smaller than it normally does, and therefore it can't completely cover up the sun, and you get a thin ring of sunlight around the dark patch of the moon.
Which is very spectacular.
It is really quite spectacular. Things, yeah. They sometimes call this a ring of fire eclipse. Yeah. Now, that is going to be seen, that annular eclipse where it covers up and you get a ring of fire, that's going to be seen through Central Africa and then going through Southern Asia. But other places in the world won't see that. They'll see a partial eclipse. So for Australia at least, there will only be a partial eclipse seen, and only from the very northernmost parts of the country. So Darwin will see it,
Cape York,
and the tip of Cape York. That's it. Yeah. So mid-eclipse as seen from Darwin will occur just after 6 p.m. That's on the 20th, and about 6:15 p.m. from Cape York. Now, there are quite a lot of people in Darwin, of course. It's a fairly big city. There aren't too many people in Cape York, so not a lot of people are going to see this compared to some eclipses that go through ginormous cities and lots of urban areas. But still, anyway, it's worth having a look if you're up that way. So annular eclipse of the sun, which is partial from Australia, on June the 21st.
That's Jonathan Nally, the editor of Australian Sky and Telescope magazine. And don't forget, if you're having trouble getting your copy of Australian Sky and Telescope magazine from your usual retailer because of the current lockdown and travel restrictions, you can always get a print or digital subscription and have the magazine delivered directly to your letterbox or inbox. And subscribing's easy. Just go to skyandtelescope.com.au. That's skyandtelescope.com.au, and you'll never be left in the dark again. And that's the show for now. SpaceTime is broadcast on Science Zone Radio by the National Science Foundation in Washington, D.C., and through both iHeartRadio and on TuneIn Radio. Or you can subscribe and download SpaceTime as a free podcast through Apple, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Spotify, YouTube, Audio Boom, Podbeam, Android, Castbox, from SpaceTimeWithStuartGary.com, or from your favorite download podcast provider. You can help support the show and the work we do by visiting the SpaceTime online shop and grabbing yourself a few goodies, or by becoming a SpaceTime patron, which gives you access to commercial-free double-episode versions of the show, as well as bonus audio content and other rewards. Just go to our Patreon page through SpaceTimeWithStuartGary.com for all the details. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, at SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to www.facebook.com/SpaceTime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.